Volume versus density. That's right, volume up here. This is another video, yep. So who knows what volume is?
Wait, isn't like volume like the car volume?
Okay, a lot of students say that actually.
How big something is.
Okay, so first we had car volume. Car volume is not correct though. Different type of volume.
Like how wide something is? Or like
Okay, this is not working. There's just no way to win here, is there? Okay, car volume is incorrect. Bell has the best definition. It's quite simple. How big something is. How much size, or the size of an object. Let's say that. So, for instance, let's take a pencil versus the microwave. Which one has a bigger volume? Microwave. How about the microwave or my water bottle? Microwave. How about a truck or a school bus?
school bus.
School bus, yep. So it depends on the truck. If we're talking about a semi-truck, then maybe that's bigger.
Yeah.
But a normal truck is smaller than a school bus. So it's just the size. Some of you might be familiar with a formula. And I think actually Gigi was saying it before. Do you remember the formula you were saying? Yep, length times width times what? Height. So that's a good formula for volume, but that formula only works for cubes. So a lot of volumes you can't find using that formula. Like a human's not shaped exactly like a cube, so you couldn't use that formula for a human, right? So all it is the size of an object, okay? Now here's a question for you. Even though objects are different sizes, some of them might be small but kind of heavy, or big but kind of light, okay? So for instance, my ring that I'm holding in my hand, but people watching the video can't see, my ring is small but kind of heavy. Like you can feel the weight of my ring, okay? And in contrast, what about a balloon? A balloon just filled with air. So let's draw a balloon filled with air. It's a lot bigger than my ring, but it's really, really light, right?
Yeah.
So we say that the ring is dense, has high density. I'm just going to write that because it's way easier. The ring has a high density, and the balloon has a low density. Okay? So its density is just how much weight it has versus how much volume it has. And of course, can't move this. Whatever. All right. So let's talk about density over here. So as you might suspect, there's a formula to calculate density. And it's pretty easy. Who remembers what it is? Oh, no one remembers the formula for density? Shoot. Okay. So remember, we always start with what we're looking for. So density equals mass divided by volume. Okay? So let's say we have an object with a mass of what? What do we want our mass to be? Who has a favorite number? 12. Okay. Mass of 12. And the mass is in what units? Do you guys remember the units? It's not pounds. Kilograms. You got it. So kilograms. Okay. And then the volume, the units is going to be something else. It's going to be in meters cubed, which means you can think of it like this. 1 meter going up and down, 1 sticking out like this, and then 1 sideways like that. So it's 3 dimensions, one going up, one going to the side, one going back and forth, okay? So that's what a meter cubed is. And let's just pick a volume of 0.5 meters cubed, okay? So we have this mass, we have this volume, and now we can calculate the density, okay? So the mass is 12. What do we divide the mass by to get the density? According to the formula. Here's the mass. What do we divide it by to get the density? What does V stand for here?
Volume?
Volume. Okay. Wait, what'd you say?
I thought I heard you say Jesus, I said
Oh, yeah, it's not Bagnall. Okay. So, and our volume is what? 0.5. So our density is 12 divided by 0.5. Who wants to do that for me in their calculator? So our density is 24 kilograms per meter cubed. Meter cubed. Now, this doesn't really mean anything to us right now, but here's something that makes it important. So one important thing of density is if something will float or sink in water, okay? So for instance, my ring is small and heavy, and if I throw this in water, will it float or sink? What do you think? Sink. Okay? So the ring has a high density, but if I put this balloon that I filled with air, will it float or sink in water?
Float.
Float, that's right. So the density of water is this right here. It's 997 kilograms per meter cubed. So does that seem like pretty high density or pretty low density? It's pretty high, right? Water is pretty dense. That's why if you're carrying around like a gallon of water, like it's actually got some weight to it. You know what I mean? It's pretty heavy. So is this thing going to float or sink? If it's lower,
Sink.
well, if the density is lower than this number, like 24 is smaller than 997, it's actually going to float, okay? Because it's light. So this object is pretty light. So yeah, if it's lower, low equals float. Float. And then let's do another one. Let's have a mass of 15,000 kilograms, or excuse me, 1,500 kilograms, and a volume of 1 meter cubed. So 1,500 divided by 1 equals what? What's anything divided by 1? Yeah, 1,500. That's an easy one. So this object has a density of 1,500 meters cubed. So will this float or sink? Remember, this one was lower, sink. Yes, that is right. So if the number is higher than the density of water, I'll circle the density of water here. If the number is higher than this number, it's going to sink. So high equals sink. Okay, so if you remember, on your project, you have to calculate the density of your object. So remember, the density is just the mass divided by the volume. And where do you get the mass of your object? Remember? We created the mass when we were calculating the mass and the weight. So you already have the mass. You chose a number, so you're going to use that same number. And then you create the volume as well. You can come up with whatever volume you want for your object. But the key is using the mass and the volume to calculate density. Okay? And then you have to see if the density of your object is enough to make it float or sink in water. Okay? Yeah, it's not too complicated. Remember, this is a pretty easy like introductory project for you guys just to get used to projects. Okay? All right, any questions about volume and density right now? Nope. Okay.